Okay, we're going to talk a bit now about analyzing loans. We're getting into the debt portion of financial math. So, this is from your textbook on section 2.1. Might be able to spell here in a moment. Analyzing loans. So, we'll talk a bit on the debt side of things now. Now, debts, if you go to borrow things, so you're borrowing money for a car, you're borrowing money for a home, borrowing for various reasons. A lot of the language is very similar to that we talked about with investments. You might talk about a principal value or value borrowed, that sort of thing. You can still have an interest rate, you can still have interest compounding over time. Only now, instead of that interest giving you money, that interest is taking money away from you, the cost of borrowing money, for instance. But a lot of the math works out the same as well. So when we're talking about debt as a whole, um, we have the same formula for compound interest equals P times 1 plus I to the n, and all the variables mean the same things that they meant before. Only now your future value is an amount of money you would owe on the debt as opposed to an amount of money you would get from the investment. Um, a few terms that will crop up that we'll talk about. Now we'll only really deal with math on sort of the last one of these, but you will see terms like collateral, and collateral is usually a thing of value accepted by the loaning institution as security on a debt or as security on a loan. And basically, that's something that the loaning institution can then take if the loan terms are not met. So, for example, if I were to go to the bank and say, "Bank, I'd like to borrow $100,000," the bank might look at my credit and say, "Your credit's not great. You're going to need to put something up on this loan as collateral." And I might say, "Okay, what if I put my truck as collateral?" And they say, "Okay." So then, if at some point I don't live up to the terms of the loan, they could then seize my truck because I used that as collateral for the loan. We also have, this was going to talk about here. Oh yes, mortgage. Most of you have probably heard of these before. But a mortgage is basically a special kind of loan, a special type of loan used mainly for real estate purchases. So basically, I went to the bank and wanted to take out a loan to buy a home or to buy a piece of land. They would just call that loan a mortgage, but it would act just like any other loan would. One that will crop into our math a little bit is the down payment. Now, certain kinds of loans will require down payment. Mortgages are one example, and probably the most common example of that. Where if I wanted to go, say, and borrow $100,000 from the bank for a mortgage, they might say, "Well, okay, but you have to put 10% down in order to get this." And I should restate this from the start. Let's say I wanted to go and buy a home that was worth $100,000. And I go to the bank and I say I need a mortgage to buy this house. The bank will say, "We need to see that you can put up a down payment of 10% of that value. And then we will give you the rest of the money in a loan." That would mean I would need to come up with $10,000 on my own, and then the bank would loan me the remaining $90,000. So down payment is an initial payment on a purchase that a loaning institution, a lending institution, may require in order to grant a loan. And again, most commonly used in mortgages. So, as I say, for example of that, if I were to go to the bank to get a mortgage for a $100,000 home, and the bank has a policy of requiring I'll say 15%, that would mean that I would need to come up with $15,000 on my own, and the bank would loan me $85,000. So down payments are required in mortgages. A lot of loans don't require them, but mortgages are a fairly common loan, and they do often require a down payment. In fact, I think nationwide in Canada there's a requirement for either a 10 or 20% down payment on a mortgage for a home. Yeah. So the more expensive the home, the more of a down payment you need to have up front in order to be able to get a mortgage to afford it. Okay, and as I said, for the rest of this, the math is fairly similar to what we did before. Your solver will still work in the same sort of way for these things. You just end up changing where a positive or a negative sign crops up. And then you do a lot of things the same way. Anyone who's sort of following along in section 2.1, there's also something in there described as an amortization table. I'm going to deal with that in our next discussion on here, because that's going to involve using a spreadsheet, which I will be able to show you, but I don't want to stick it into this lesson. So, for a few examples, we're just going to dig right in and look at example 2 that is on page 83 of your textbook. And this has Trina getting a loan. His employer loans some money, and that happens sometimes as well. Some organizations will have programs in place to loan money to their employees at a certain rate. Usually larger companies may have something like that in place. In this case, Trina's employer loaned her $10,000 at a fixed interest rate of 6%, compounded annually, to pay for college tuition and textbooks. The loan is to be repaid in a single payment on the maturity date, which is the end of 5 years. And we're basically asked in this, there's a graphing section in this example, which I'm not going to get into because we're not going to worry about that end of it too much. But largely this example gets into talking about the difference between having that interest compound annually and having it compound monthly. The A part of it, well, actually I'll describe her situation. She's borrowing $10,000, so that means that her principal for her loan is $10,000. The interest rate is 6%. And the term is 5 years. Now the A part of this is an annual loan. So, to figure out how much she owes, we can either simply use the formula, in which case my A value is what I'm looking for. My P value would be the $10,000. My I is simply going to be 0.06 divided by 1. And my N would be 5, since it is 5 single-year terms. Working that out, and you'll notice again the math is exactly the same as if we were using this to figure out an investment value, the future value of an investment. 10,000 times 1 plus 0.06 over 1, not that I really need that, to the 5th power. Trina will owe $13,382.26. We could also use the solver. In the solver, your N would equal 5, your I would be 6. Your present value, I will note the one difference here is your present value now is a positive number. That's because you have gotten this $10,000 at the start of the loan, at the start of the whole transaction. So that's a positive money that you have right then. What will then happen, and there's no regular payments on this, is your future value will turn out to be negative because that's ultimately what you're paying back. And 1 period per year. And if I go ahead and solve that, gaps under finance in the solver, 5, 6, 10,000 with no regular payments, 1 pay period and compounding period per year. Solving on that, 13,382.26. And I'm fine with whichever method you use. And we would say there that annual compounding Trina owes, or will owe, we'll run out of room. Cheat a little bit here. $13,382.26. So again, the math of this, very similar to what we did with investments, just being careful if you use the solver that the signs go on here. And I didn't mention and should notice that my sign in this future value is a negative number. And that's just indicating that you owe that money at the end of the term rather than that it's money that you're getting. I'll take a quick look at the B part of that same question. And the B part largely just has this set up as a quarterly loan. Bottom of my page is in there somewhere. Okay. Top. Shouldn't have moved the camera. Apologize for the delay here. Okay. Sorry about that. Part B. Same principal borrowed, same rate, same length of term, only now this is compounded monthly. So this means that my n value is going to be 5 times 12, or 60. And my I value would be decimal 0.06 over 12. If I use the formula, that'll work out my future value to be equal to the present value times 1 plus decimal 0.06 over 12 raised to the power of 60. Which, well, I can really just cheat here. Bring this back up. And that comes out to $13,488.50. Or again, we could use the solver to get the same thing. Your n is 60, your interest rate is 6%, your present value is $10,000, you're making no regular payments, your future value is what you're looking for, only now, at the bottom, you have 12 periods per year, not just one. We set that up. I don't have to change too much in here. That becomes 60, these become 12, and I solve for my future value again. And this gives me negative $13,488.50, which is not too surprising. So then I can say, with monthly compounding, Trina will owe $13,488.50. It's worth pointing out that that is a number here, 13,488.50 minus 13,382.26, or $106.24 more than with annual compounding. So it's worth pointing out that the more compounding periods you get on an investment, the better for you. The more compounding periods you have in a debt is worse, which is why you don't often see loans through institutions being compounded annually. Usually they'll talk about them being compounded monthly or less so. Okay. So that was actually the C part of that question. The B part involved the graphing. More examples. I also wanted to look at example 3 on page 86. Which talks about Annette. She wants a home improvement loan to renovate her kitchen. Her bank will charge her 3.6% compounded quarterly. She already has a 10-year GIC that will mature in 5 years when her GIC reaches maturity. Annette wants to use the money to repay the home improvement loan with one payment. She wants the amount of the payment to be no more than $20,000. How much can she borrow? How much interest will she pay? Okay, so it's worth noting that the GIC part is mostly pointless, other than to say that she wants to borrow this money for 5 years. So we know we want a 5-year term for this borrowing. We don't know what the present value is. We don't know what the initial amount she wants to borrow is. But we do know that she wants the future value to be $20,000. This is at a 3.6% rate, compounded quarterly. So this means that my I would be decimal 0.36 over 4. and we're looking to find the principal value. Oh, and if it's compounded quarterly, that means my end value is going to be 5 times 4, or 20. Now, I might, for a quick run through, just use the formula for this one. My formula is rearranged for A, but it's not too bad to rearrange it for P. So in this case, that's going to be 20,000 divided by 1 plus decimal 0.36 over 4 raised to the power of 20. And if I work that all out, I get $16,718.86. So in the statement, Annette can borrow $16,718.86. She will pay $3,281.14 in interest, as that's the difference between what she borrowed and what she'll pay out at the end. Alright. And onward. A couple more examples where you're solving for different variables within the whole loan. Now, for these next ones, I'll probably use the solver and the old graphing calculator. Okay. This next example is example 4 on page 87. Where we have Jose negotiating with his bank for a mortgage on a house. He's been told that he needs to make a 10% down payment on the purchase price of $225,000. Then the bank will offer a mortgage loan for the balance at 3.75%, compounded semi-annually with a term of 20 years and monthly mortgage payments. So now we've got a couple of different things going on. So the solver is really the best way to go for this. Working this out by hand would be unpleasant, to say the least. So the initial cost is $225,000. Of which 10% is paid with a down payment. Therefore, Jose is borrowing $225,000 minus 10% of $225,000. So he's borrowing $202,500. We are asked a few things about this. We're asked how much is each monthly payment going to be for a 20-year term, how much interest will he end up paying, and how much will he pay off altogether. So, a few things that we know now. And this will be set up in the solver. We know that this is a 20-year mortgage with monthly payments. And I do want to stress here, N is based on pay periods, not compounding periods. Up to this point, in most of our questions, those have been the same thing, so it didn't make a difference. But when your pay periods are different than your compounding periods, N is based on the pay periods. Our rate given in the question is 3.75%. Now Jose is borrowing $202,500, which is the difference between the value of the house and the down payment that he had to come up with from some other source. The regular payment is what we're trying to work out. Now the future value of this, if you ask yourself the question, okay, how much should he owe at the end of this 20-year period? Well, at that point, he should have paid the entirety of it off. So the future value of that debt should be 0 when the term is done. Pay periods per year. Said he's making monthly mortgage payments, so that means he's making 12 payments per year. However, the interest is only being compounded semi-annually, so there's only 2 compounding periods per year. Let's say that's from monthly payments, and this is from semi-annual compounding. All right, so if we drop that all in, finance, KMB solver, I will point out you can do simple calculations in each line, so I don't even have to work out what 20 times 12 is, it'll do it there. 3.75% interest on the loan, borrowing $202,500. Future value drops down to 0, 12 pay periods per year, 2 compounding periods per year. Put that all together, I can solve for the monthly payment amount, $1,197.55. Notice that it's negative because that's money Jose is paying out each month. Okay. So then we're asked a few questions about this. A. Jose pays $1,197.55 each month. B and C kind of go together because it asks how much interest does he end up paying and how much does he pay in total. Alright, so let's work a couple of things out. I'll probably end up doing part C before I do part B. Jose pays the $22,500 down payment plus this many months worth of payments and I just want to get that number off the gate there. 20 times 12 times 1197.55. So overall, Jose pays $309,912 for this $225,000 home. That's the joy of borrowing. And for interest, he paid the bank $287,412. He borrowed $202,500. So if I take the difference there, $84,912 in interest. So Jose paid $309,912 in total. for his house. Of that money, $84,912 was interest. Which is the main reason why people try to avoid debt if they can help it. Now, a lot of times you can't help it, but if you can, I mean, this is money, effectively, that Jose was just paying to the bank in order to borrow money from them. He paid $84,912 to borrow $202,500 over a span of 20 years. All right, one last example, and then we'll call it a session. This is, shockingly enough, as I'm sure you'll think, example 5, following in progression. Example 5 from page 89. And this one you're being asked to compare a couple of different loan options, which is part of life if you're borrowing money. You want to check around and see what gives you a better deal. This is example 5 off of page 89. And we're told that Bill has been offered the following 2 loan options for borrowing $8,000. What advice would you give? And I'll list the big features of the 2 different options here. Option A, this is for borrowing $8,000. In option A, it's 4.06% interest, compounded annually, with annual payments of $1,805. Option B, also 4.06% interest. In this case, it's compounded weekly, with weekly payments of $34.62. Now, there are a couple of competing differences here. If you just had the compounding differences, the weekly compounding would end up generating more interest than the annual compounding will. However, since you're also paying things off regularly, making the weekly payments actually helps drive the interest down a bit, because then there's less amount owing to charge interest to more regularly. So the annual and weekly compounding, that difference is competing against the annual and weekly payments. So we'll take a look at which one works out better for Bill here. I go through option A on the solver, and these are, well, we don't know what N is. We don't know how long it's going to take him to pay off this loan at this rate. Know that he's getting 4.06% term on the loan, or terms on the loan. He's borrowing $8,000. He's making regular payments of $1,800.05. He wants to have paid off the whole loan by the end of the term, obviously. 1 payment per year and 1 compounding period per year. If I work all that out for option A, I get an N value of 4.999990602. For all intents and purposes, I'm going to call that 5. Or it would take 5 years for Bill to pay off this loan. Now I'm going to take a look at option B, but then I'm going to talk about them each for a minute or two, because there's a couple of things worth looking at in order to see which loan might work better. Once again, I don't know how long it's going to take to pay this off. 4.06%, borrowing $8,000, paying $34.62 to bring it down to zero, but doing it weekly with 52 periods per year. So if I work that out for option B, and I'm going to hold on to a few decimals in this case. 2, 9, 9. I'll explain why in a second. So it's worth noting that option A takes 5 years to pay off, and overall you pay 5 times 1,805 cents, or $9,900.25. And those are sort of your two big points of interest. How long does it take to pay it off, and how much do you pay out overall? Now, to work that out at option B, there's a little bit more work here. So since this is happening weekly, he's not going to have this paid off until the 255th week. And again, these are weekly periods. So total time, or the term, I should say, total term is going to be 255 weeks. Or 55 divided by 52. 4 years, and I stated in terms of weeks instead. 4 years, 47 weeks. I did that right. Yes. Now this is about 5 weeks short of 5 years. So that's one benefit to option B, is that it's a little bit shorter. And the total payout, and this one will be why I held on to those decimals. For 254 of those weeks, he's got to pay that $34.62. But that means in that last week, he owes less than $34.62. So in that last week, he pays a bit less than that. So his total payout is actually going to be $254.9299 times $34.62. Or $8,825.67. So, I feel I missed a zero someplace. Give me 1 second. I want to check this number, because I think I did that wrong. 5 times 1,805 cents. 9,025, not 9,925. Apologize for that. Okay. So if I compare the two, option B really looks like it's the better overall. First of all, you're paying it off a little bit sooner, 5 years sooner, but you're also paying almost $200 less in interest on it. So of the two options, option B really does look like it's the better choice of the two. Even though the interest is compounding weekly, which would tend to drive that up, paying it off weekly tends to drive it down more. So option B looks like the clear winner. Alright, that's all that I have to say about analyzing debts for today, for this session. Like I said, my next talk on this will be a slight extension on this in using your spreadsheets to work out some things. There is a spreadsheet app within the Google Classroom, and we'll look a little bit about how to use that in the next video. All right. Thanks for your time, everybody.